everyone, and welcome back to Day 2 of Translation, Section 4.1. Today we're going to be talking about compositions of translations. So that is more than one movement at a time. And first we need to define what rigid is. Rigid motion, or it's also known as isometry. And it's when you have a transformation that preserves length and angle measure. So your shape doesn't change at all. The original shape is completely congruent to the final shape. And we've been talking about translations, and now we're just going to actually define a translation. A translation is a rigid motion. And then the composition theorem says the composition of two or more rigid motions. So let's just get into some examples so you can see exactly what we need to do here. And for this one, this first example, you are given a line segment, RS, and we are told to do two things to this line segment. First, we're told to follow this rule where it says take this original XY, and then your new points are found by taking X and subtracting 1, taking the Y value and adding 4. That'll get you your new set of points. Then you're going to take your new set of points and you're going to apply the second rule. We're going to take those points and we're going to add 4 to our X values and subtract 6 from our Y values. And then that will give us our final coordinate points. So you always want to go in order. Whatever's on top you want to do first, whatever's on bottom you want to do second. So we are first going to work with the translation of XY yields X minus 1, Y plus 4. And our original R has the coordinate point -8, 5. And our original S is -6, 8. So following this rule, we take our original X, which is -8, subtract 1, take our Y value of 5, add 4. And that gives us -9, 9. And that's for our R prime. So R is the coordinate point, -9, 9. We're going to follow that same process for S prime. So take our original X, which is -6, subtract 1, original Y, which is 8, add 4. We get -7, 12 is our S prime. Now, these coordinates here are the new coordinates that we're going to work with when we apply this second translation here. Writing XY yields our second translation here of X plus 4, Y minus 6. Our R prime is -9, 9. S prime is -7, 12. And we're going to apply the rule, so -9 plus 4 and 9 minus 6 gives us the coordinate point -5, 3. And that is labeled R double prime because it's the second time that we've reflected our original point R. So S prime, -7 plus 4, 12 minus 6 gives us -3, 6 is our S double prime. So now we're going to plot those 2 points because this will give us our final image. Again, this is our pre-image, and then what we're about to plot is our image. So left 5, up 3 is our double prime, and then -3, 6 is S double prime. So that is our final image for our composition, or for our composition. Let's do a second example. We are going to do the exact same thing we just did in our previous example. This time we had to figure out the points of our figure, so I wrote them all down. And we're going to do our first translation the one that's listed on top first. So xy yields x plus 3, y plus 2. So if we work with k, that is negative 4 plus 3, 8 plus 2. And that will give us our k prime, which is negative 1, 10. And let's do the exact same process for L. We have negative 7 plus 3, 4 plus 2 equals negative 4, 6 for L prime, and then M comes from negative 2 plus 3, and then 1 plus 2 gives us 1, 3 for M prime. Now we're going to take the new points, our primes, and apply the second translation, which is xy yields x plus 2 and y minus 9. So k prime is negative 1, 10, and that gives us negative 1 plus 2 and 10 minus 9, or 1, 1 for our k double prime. L prime was negative 4, 6, and then we get negative 4 plus 2, and then 6 minus 9, or negative 2, negative 3 is L double prime. And finally, M prime is 1, 3. Applying the rule, x plus 2, we get 1 plus 2, and then y minus 9, we have 3 minus 9, or a new coordinate point of 3, negative 6 for M double prime. So those are the 3 final points of our image. So 1, 1 is k double prime, negative 2, negative 3 is L double prime, and 3, negative 6 is M double prime. So connect those points. And that's our final triangle. That's our final image. We have 2 other parts to this. And part B says to rewrite the composition as a single transformation. This is known as a rule. So what we want to do is essentially come up with a single rule that would translate KLM to K double prime, L double prime, M double prime in one single translation. So X, take your original XY, and it's going to yield what? Well, if we take a look at this, all points have followed this green vector here. So if we break that up into its components, its x component and its y component to form that right triangle, how far left or right did we move? How far up or down did we move? If we take a look at the x component, we are moving to the right 1, 2, 3, 4, 5 units. And then our y component is going 1, 2, 3, 4, 5, 6, 7 units down. So we're going down 7. So that means we take our x for every x value we have and we add 5. And for every y value we have, we take away 7. So we subtract 7 because we're moving down 7. The last part asks us to write the composition in vector form. So we want to know how far we moved with this vector. And we already broke this vector down into its components of right 5, down 7. So all we have to do is write these numbers in vector form. And that's going to look like this. And that's your final answer for that. So in this lesson, we just went over a composition of translations, which is 2 or more translations happening in the same problem, and you're drawing your final image from that. And then we were able to write a single transformation based on that composition, and then also write it in vector form. That's it for today's lesson, and I will talk to you soon. Thank you.